Now let's dive into actually using Python to explore some of these data sets and look specifically at measures of the center and explore different properties of the measure of center. So as with everything I do, I want to dive into some data. And let's go ahead and use the party data set again.
Perfect. I will go ahead and import pandas and get the party data set ready.
So as just a quick reminder, the first 3 lines of code we're always going to write is import pandas as PD, then df is equal to pd.readcsv. And finally, we're going to specify inside the read CSV the party data set, which all of these data sets, we're just going to use the one I have posted on my faculty website. That's going to be https://waf.cs.illinois.edu/discovery. And because we're working on the party data set, we're going to do party.csv. So I want to discover different properties of the measure of center, because that's what I love to do. And kind of when I see it actually happen, it's going to give me more insight of how the measure of center actually works out.
Perfect.
So the first property is we're going to add or subtract a constant. And a constant means a fixed value that doesn't change. So we're going to add or subtract just a fixed value to all observations. So to discover the first property, we will find the mean and median of the data set and then add, or we could subtract, the same number from every piece of the data and then find the new mean and median. And then we'll do some analysis. Yeah.
So we want to know basically if you have a data set and you take every number on the list and add or subtract a number, how does that affect the mean? Did you say mean and median?
We'll look at mean and median.
Okay, perfect.
So the first thing I want to do is I want to find the mean and median of some values. So I'm going to go ahead and say, let's go and let's just look at several, but we'll see all of the data on the screen. But I'm going to just focus on the several value.
Sounds good.
So to find the mean of everything in our data set, we can simply type df.mean, and Python's going to calculate the mean of every single column in our data set and present us the mean of each column.
I had a quick question, Wade. How come we have to put those parentheses after mean?
So almost every call you make in Python, and that's a great question, is going to be a function call where we can specify extra arguments inside of the parentheses. By having open close parentheses, we're saying we don't need anything special.
Got it.
And it's going to be very rare we don't have these parentheses when we're asking a object like a data frame to do something.
That makes sense. So I just ran df.mean and got the mean of all of the columns.
So I'm going to look at the variable several. So looking at the variable several, what was the mean of the variable several?
So it was 13.1.
13.1 is the original data set's mean for several. And I want to do the same thing with median. And to do that, we can just type df.median.
Perfect.
Open close parentheses.
And the median was 8.
8. So just as a reminder, the median is the center number. So if we sort all of the number is going to be 8 is the median number, and the average of all the numbers. So if we add them all up and divide by the total count, we have 13.1. So now we want to modify the data set by adding a constant to all of the variables. So I want to add a constant value. Carly, what's your favorite number?
6.
6. Okay, so we're going to add the value 6 to each observation of several. So to do that, we're going to go ahead and say we want to change the value of df at several to a new value that is the old value of df.several plus 6.
So we want to actually change that column, not add a new column.
Correct. We are actually changing the data itself. So we're going to say df at several is equal to the old value of df at several plus 6. And what this is going to do is row by row, it's going to look at what the old value of several is, add 6, and replace that value. So if you run that, you should see Python's going to do absolutely nothing if you run that cell, right?
Nothing happened.
But behind the scenes, it's changed all of those values. And now, can you run df.mean for me again and see what the mean is?
Sure. df.mean, and for several, I got 19.1.
19.1 is after the modification. So before is 13.1, now it's 19.1. And let's run df.median and see what changes.
Perfect. So for the mean, it actually increased by 6.
Yeah, that's a great observation. So we basically got plus 6.
df.median, and the median is 14.0.
14.0.
Also increased by 6.
Which increased by 6. So that's awesome. So we can look at this analysis. So you can help me out on this, Carly.
Yeah.
So how did adding or subtracting the same number to all of the observations change the median values?
So basically, it looks like if we add or subtract the same constant to every value on the list, then all we have to do to find the new median is add or subtract that constant to the original median.
So when we add or subtract the same constant to all values, the mean and median both change by that constant.
Yes. And this will always work with any data set as long as you are doing the same thing to every value on the list. If we only added 6 to the first number on the list, then that would not hold true.
So we discovered our first property. The first property is if we add or subtract a constant to all of the data, we find that adding or subtracting to each individual, or to all of the data, the mean and median changes by that exact value.
Exactly.
So I have a second property. I want to do the exact same thing, but multiply.
Okay.
So we've already used several. So Carly, what other value do you want us to use?
Let's do scores, because that's the weirdest word.
So we're going to look at the variable scores. And I want to see what happens when we multiply or divide, which again, division is just multiplying by a fraction.
Right.
So we're just going to multiply. And again, to find the mean and median, to find the mean, we'll just simply say df.mean. And Carly, can you tell me what the mean of the score was?
Yes, and it's actually, I just noticed the variable is called scores of, so it does have a space. Ooh, should I still use that one?
No, that seems great. That's a great, so we'll have to be certain to use the square bracket notation instead of dot notation. And the O is capitalized, right?
Yes, the O is capitalized. So the, do we want the mean or the median?
Let's do mean first.
Mean first is, for scores of, is 78.8.
78.8. And then for median, I can run just df.median. And what is the median of the scores?
75.
75. So very close. Their mean and median are only differing by a small amount.
Mm-hmm.
And now we want to modify the data set by multiplying each value by a constant. One of my favorite numbers is 3. So I'm going to say, let's multiply scores of by 3. So we can say df at scores of is equal to df at scores of, again, replacing the old value of scores of with the new value, but multiplying by 3.
All right, so Python, nothing showed up different in Python, but.
So as it worked behind the scenes, and we can actually look at df, if we just type df real fast, we know that if we multiply numbers whose average and median's around 75, we should see the numbers should be in the range of like high 100s to 200s.
Yes, that's exactly what we have. I even see a 600 on here.
Oof. So let's go ahead and look at now the new mean of the data.
So the new mean of scores of is 236.4.
236.4. And how about the new median using df.median?
The new median is 225.
225. So now we've got this interesting analysis question. How did multiplying and dividing the same number to all the observations change the median? So if we look at this data, 75 times 3, that's 225.
Oh, yeah.
And then in Python, can you just do 78.8 times 3? Just double check our math.
8 times 3, 236.4. Oh, that's exactly what we got.
See.
Good.
So Carly, how did multiplying or dividing all the numbers change our observations?
So it was pretty much the same as before. Our mean and median increased by a factor of 3 when we changed every single observation by multiplying it by 3.
So when we take the data and multiply it by some constant, any constant, it's going to result in the mean being multiplied by the constant and the median being multiplied by that same constant.
And Wade, really quick question. Will this work if the constant's negative as well?
So that's the very last question. Does this actually work for negative numbers? And honestly, I'm not sure. Can we actually let's look at the word
We might
mini.
as well test it out. Yeah.
So can you give me the mean of mini?
Sure. The mean is 30.1.
And then let's do df at mean is equal to df of mini equals df of mini times, actually my favorite number is -3. So we used just 3 last time because I didn't want to throw negative numbers in here. And let's see if we multiply it by -3. And
Why
then,
is your favorite number -3?
long story, but
Okay.
basically I feel like negative numbers are a little bit lost sometimes. They're kind of lonely.
They don't get any love.
I know. And -3 is the first, and 3 is the first prime. So -3 is the first negative prime.
All right.
So if we multiply everything by -3 and then find the new mean,
The new mean actually is negative 90.26.
90.26, which I'm going to round to 90.3.
Yep.
And so 30.1 times -3 is indeed 90.3.
So it does work for negative numbers as well.
Yes. So there's one final property we want to go through, and that is how sensitive these numbers are to outliers. So we want to discover if we change the data and then find the new mean and median by simply adding a new record to our data set, how does that change things?
That's a good question because now we're actually just manipulating one number. We're adding it instead of changing all of the numbers.
Yes. So find the mean and median before, which variable do we want to use?
Let's see, which one? We haven't used sum.
Sum, S-O-M-E. So we're going to look at sum. And I want to find out what the median of sum is. And one thing we can do to just see a little bit of difference is we can actually say df square bracket quote sum square bracket dot mean. So using the square bracket saying df at sum, I'm just going to look at now just the sum column. So by doing this, now I shouldn't see all of the data being displayed and all the different variables. Now I should just see the variable or the column sum.
Yep, and the mean is 12.4.
12.4. And we can also use the dot notation because there's no space in sum. So we could also have said df dot sum dot median.
And the median is, oops, I spelled sum wrong. S-O-M-E.
It's a
The
tricky
median
one.
it's S-U-M. The median is 10.
10. Awesome. So we want to modify the data set to add a new record. So the description says add a new record with sum. We'll change this to sum since we're working with sum. This could be any variable in the data set,
Right?
where it's observed to be 1 million. So this is going to be a little bit of a crazy notation, Carly,
Okay.
because we're actually inserting data inside of Python, which is something we're going to either create all the data in Python or none of the data in Python. So we're going to just append to the end of this.
Okay.
And we're going to do df.append. And this is going to be really strange notation. And you'll see this come up when later in the series when we look at simulation. But we need to use a curly brace.
Found it.
And then we're going to say, in quotes, sum, using the correct capitalization,
Correct spelling.
has colon 1 million. So you can't use commas in Python. So you need to type 1 followed by 6 zeros without any commas. And then if you close out the parentheses and run it, you're going to see that it should almost work, but it'll probably give you an error.
It says can only append a dict if ignore index equals true.
So this tells us that we need to add another parameter to this.
Got
so
it.
after the end of the curly brace and before the parentheses, we're going to say that we're going to ignore underscore index. And we're going to say that is equal, single equal to true. And if you run this, what do we see?
It worked, and I have an extra row at the end of my data set that only has a value for the column sum of 1 million.
Awesome. So when we just wrote this line, when we did df.append, and we only appended this, we only did this temporarily, but we want to save this. So if you go back to that line and say df is equal to df.append, I want to save the fact that we've appended this to our data frame. So now we've got a new data frame that contains all of our old data plus that one new record.
Got it. Done.
So now we can go back and let's see after the modification, let's look at df.sum.mean again and see what the new mean is after we added somebody thinking sum was 1,000,000%. So Carly's going to type df.sum.mean.
And we got 556.1. So 17556.1.
Wow. So our mean went from 12.4 to 17,000.
It's huge.
It's huge. Let's see if the median does the same thing.
Sounds good. I'm going to do df.sum.median. And we get 10.
10. So now we can do a little more analysis. So how did adding a record to the sum change the mean and median?
So the mean, it changed it by a lot. It increased it drastically. Whereas the median actually stayed the same.
So the mean increased by a large amount.
Yes.
And the median actually stayed the same.
Yep.
Carly, by looking at this analysis, we see that the mean is extremely sensitive to what you called an outlier. By just adding a single value, it went from the value of 12.4 to 17,556, a value that doesn't even make sense in the context of this data,
Yeah.
while the mean stayed exactly the same, that it's not nearly as sensitive to outliers.
Yeah, so it looks like the mean and median are slightly different measures of center, and sometimes it may be best to look at the median, sometimes it may be best to look at the mean, or sometimes it's best to just go ahead and report both.